Okay, so get out your textbooks.
I left mine back at
Well, that's okay. That's maybe you don't even need it. Here, I'll just put this one up here.
I kind of left mine downstairs.
That's fine. I'll just read it. Okay, I want to look at one of these. Let's just pick an example, and I'm just gonna pick.
Why are we in the book, Wes? Are we in
Huh.
the review?
Yeah, we are, but I want to pick a word problem. Yeah, I know, but there's still a lot of questions about how to deal with turning word problems into equations. So here's the one we're going to take a quick look at. Then we'll get out of here. Okay, I want to look at the one about construction business. So we've got, it says has everyone seen this one? You may not have gotten this one, but I'll just paraphrase it. So you're an accountant for a construction business and are planning next year's budget. You have $200,000 to spend on salaries, equipment maintenance, and other general expenses. Based on previous financial records of the business, you expect to spend 5 times as much on salaries as on equipment maintenance. And you expect general expenses to be 10% of the amount spent on the other two categories combined. Write and solve a system of equations to find the amount you should budget for each category. So the unknowns are just the amount that we're budgeting for those 3 categories. So the first thing you gotta do on these to stay organized is write down what your variables are. So I'm just gonna call X salary expenses. Y is, what's the next one? Equipment maintenance. And Z is general expenses. Is that what it was? Yeah. So those are our variables, right? Now, if they tell us that we have 200,000, we're always looking, they won't all have this, but remember, we're always looking to see if there's a really easy equation that's just a sum of all the variables. In this case, it says we have $200,000 to spend on salaries, equipment, and general maintenance. So that's equation 1, isn't it? Yes.
So would it be 5x y?
Okay, we're coming up on one of those, but the first one is just x plus y plus z is 200,000, right? Okay. Now, what about the other two? These are the kind of weird ones. Let's start by just writing the equation down, and then the second step is to put it into standard form. Okay, so how do we interpret? I'm just going to write this one sentence down. We've got to turn this into an equation. You expect to spend 5 times as much on salaries as on equipment maintenance. Okay? So we got to turn that into an equation. Now, one thing that's really helpful to do with story problems, if you can take, this is obviously an informational statement, isn't it? This is telling us a relationship between the variables, and each relationship, each separate relationship, we turn into one equation. We don't want to try to mix these up, though. That's something that smart students oftentimes want to do, is they want to start tying these things together and start saying things like, okay, well, instead of x plus y plus z equals 200,000, well, let's see. Salaries are 5 times as much, so do I put like a 5 in front of the, no, don't mix those up. This first statement is totally independent of this one, right? The first one is just saying the sum of all those expenses, and we don't know what they are yet. They're unknowns. Solving the system is going to tell us what those values are. The fact that the salaries are a lot more than the equipment maintenance, that's going to be a separate equation entirely. That's going to kind of guide the system towards x being a bigger number than y. But don't mix them up. Okay, the other thing that's really helpful is when you get these informational sentences, if you can rewrite or rephrase them, always using the verb is or are, whichever one is grammatically correct. You don't even have to be grammatically correct with these. turn it into a sentence with is or are. Is or are always corresponds to an equal sign with a math equation, right? And sometimes that's helpful to do. This is a little bit confusing. Because Trenton, your suggestion was 5x equals y, right?
Or 5y.
Okay, that'd be better, wouldn't it? But it's a really common thing to do to say, okay, 5 times as much on salaries, well, that's 5x. No, it's actually not. But it's a lot easier to see if we rewrite this sentence using is. So how could we do that now? You expect to spend 5 times as much on salaries. So we're really kind of defining how much we're spending on salaries, right? So couldn't we rewrite that by saying salary, how about salaries or salary expenses? So salaries are 5 times equipment maintenance, right? Right? Does that make sense? That's easier to see, isn't it? This turns into an equal sign. This turns into an X. And how do we say this stuff? 5y, right? See what I'm saying? So once you write that with an is or an are, it really does become a lot clearer what that equation is supposed to be. So there's our second equation, but it's not written in the right form. You got to write it in standard form. Right. Good, so we got to put the x terms, then the y terms, then the z terms equals whatever number we're left with on the other side. So if we subtract 5y from both sides, we get x minus 5y equals 0, right? Say it again if you did what?
Would you get a different answer from x instead?
In other words, if you made it negative x plus 5y equals 0, won't make any difference. And I'll tell you why. It won't make any difference because any of these equations, and this is kind of a cool feature of linear systems, of linear algebra. I can multiply any one of these equations in the system through by a constant, and it doesn't change the solution to the system. I could multiply this first one through by 100 if I want to. 100x plus 100y plus 100z equals 20 million. And it's fine. The solutions are going to be the same. Okay? So multiplying by -1 and changing the signs doesn't alter it at all. Okay? Does that make sense? I won't even do the third one, but then there's another one that has to do with the 10% stuff. If you take that statement, rephrase it using is or are, and then turn that into an equation, just put it in standard form. Just algebraically simplify it, distribute if you need to, collect all the x terms, x term on one side, y term on that side, z term on that side, whatever's left on the other side is the constant, you're set. Okay, make sense? Okay, and there's no silver bullet, but that's a good general approach to doing these things. Okay, let's get back down there and do some work.
What about the 10% part?
How do you say 10% of something?